What up, y'all? So this is the last video for data visualization. So if you're trying to find sort of the baseline for what we're talking about, if you go to the R. Davis GitHub website and you go to course materials, and then you pull down the tab for data visualization part 2. So the first video that was filmed was about color visualization tips on non-visual data interactions, using things like sound to demonstrate some sort of trajectory in a different way rather than actually plotting it. So lastly, what this final video is going to be about is publishing plots. And so using a couple different tools. One will be cowplot, which sounds funny and is kind of funny, and Plotly. So we're going to show you a quick overview of how both of those work, with the basic idea being that these are tools for exporting plots to other mediums. So maybe making like a multi-panel figure, making something that looks sharp enough that you can send it off to a journal, or making an interactive plot that you can publish as like an HTML page or something like that, and then allow people to drag around, point and click, and learn more about it. So with that, let's go ahead and get started. So I'm going to drag and I'm going to copy and paste in some of the text from the that course material web page, in part because I don't think it's good content to have you watch me like type out a whole set of plot functions, because they can be fairly long. The first thing we're going to do, though, is we're going to load the cowplot library. So library cowplot. In this case, I have it installed. You might not have it installed already. If you don't have it installed, you know what to do. Pause the video, install that, and come on back. Great. So assuming you do have it installed now, the next thing we're going to do is we're actually going to use an internal R data set, the diamonds data set. And so it's like a preloaded like base R data set. And so it's really common to see it if you like Google for plot tutorials in R, or demonstrations of how to use different plotting devices. You might see the diamonds. Oh, it's not there. Why is it not there? Oh, it's a tidyverse data set. Let me check. Maybe Iris. That's okay. Iris is base R, and I'm betting if we load tidyverse and we type diamonds, oh yeah, there's a data table or a tibble of diamond data. All right, so load the tidyverse package as well if you haven't already, and then type in diamonds into the console and observe what happens. You should, like I have an object that is about 53,000 rows long and 10 columns wide. So we're going to practice some plots here. All right, so what I'm pasting in is from that course material webpage, and it's going to be 3 different plots. So the first plot is taking that diamonds data frame, and we're going to plot the diamond clarity values. So this one's called plot diamonds. Then if you run that same object in the console, you get this sort of bar plot, which is contrasting, and I don't really know anything about diamonds. I can't lie, I've only bought one my whole life, but something about like the clarity ranking, and then something about like the cut rating. Presumably both those relate to how expensive it is. Who cares? That's not really the point here. One trick I want to show you that you might find useful. So in this case, we made that plot.diamonds object, and then you had to enter that in the console again to get it to visualize. You also know that if you just run a ggplot command directly without saving it as an object, it will visualize. A third thing you can do is if you embed that whole call in another set of parentheses, it'll do both things at once. So it'll save this plot object as plot.diamonds, and it will print the result of that plot. So embed it in those parentheses, and now we have the visual on the right-hand side, and we have the plot stored as plot diamonds. Now we're going to use the cars data set. If you type cars in the console, it show up. In this case, it's very simple. Speed and distance, and it's just two columns. Let's put that in parentheses again. All right, so we have the cylinders of cars, and we have miles per gallon in city and highway. Oh, wait. MPG is the data frame. It's not cars. I am just all confused about these. I think one benefit of these practice data sets we use is they're all so completely unmemorable that it forces you to sort of learn the problem solving part rather than memorizing. But on the downside, they're so completely unmemorable, I can't even keep it straight. And I've taught this several times. All right, so the MPG data table, this is also a tidyverse data table, and it has car data like cylinders and manufacturer and miles per gallon, city and highway. So we're going to make a second plot that plots miles per gallon, city and highway by how many cylinders a car has. Unsurprisingly here, right, if you have like an 8-cylinder stupid truck, you have like very low miles per gallon on both. And if you're driving a 4-banger, you get really high miles per gallon because that's like your Honda Civic. All right, third and final plot is the iris plot, the data plot, which we actually already typed iris in earlier. In this case, we're plotting sepal length against petal length, species fill, whatever, who cares? Just so we can check it out, we'll put that in parentheses again. All right, we got a dot plot. So let's say that for some crazy reason you wanted to show all three of these together. Cowplot provides the functionality for doing that. It's not the only way to do that. There's some other tools like Grid Extra in R that you can use. In general, the basic idea is all these plots treat sort of the plot space as some sort of grid and allow you to customize how you put different plots in different spots. So there's like very simple ones where it's like equal panels, 1, 2, 3, 4 kind of thing. There's more complex versions where you can have like panels of different size, some overlaid over another. It gets a little trickier to implement the more complex you get, but the basic idea is if you can dream up a visualization, unless it's a pie chart, it's possible to make here. All right, so we're going to use the plot grid function. And the first thing I like to do is look at the help function or read the help function. So in this case, plot underscore grid is a cowplot function, and the description is very straightforward. It is for arranging multiple plots into a grid. So the first thing I always recommend doing is just trying it without tweaking anything else. So let's just put all 3 plot objects in the plot grid, and we'll call that object panel plot. And we're going to put the parentheses around it just so it shows up. This is kind of funny. So if you've looked at a function or read a function help file before, usually ... is at the end of the function call, and it says like other stuff you can add. In this case, ... is at the beginning of the plot grid call. So what's going on here? If you read the arguments section of the help file, that ... is a specific set of ... It's a list of plots that are going to be arranged. And so what happens when you call plot underscore grid is the function looks for it just starts working through however many plots you give it at the start, then looks at all the other settings you specified, and then makes the plot. So if you give it 1 plot, it reads that. If you give it 3 plots, it reads that. So it can accommodate sort of any number, an arbitrary number of plots you feed in. In this case, we're going to feed in those 3. Okay, so if you pull up the plot window, or you are to visualize this or read about this object, you're calling like structure on panel plot, tells you that you have some sort of list object in the console, or in the visual you have this panel of plots, and they're functionally the same thing, right? Essentially, we've now associated all these plots together and said we want them to be sort of stored as like one image file. We can start to add simple things like labels and columns into that plot grid call. We're just going to put those after the plot in the call. Now, if we run that, we have this 2x2 table, which we specified, and then we have assigned grids A, B, and C. You can call it 1, 2, 3. You'll get 1s and 2s and 3s. The same thing spits out. Already you can see there's a lot of powerful stuff we can do here with customizing these plots. Okay, so let's tweak this a little bit, and we'll blow one out and show what it looks like if you want different plots to be of different size. So now I'm copying and pasting the next big code segment from that HTML file on the web page. This one is going to be called fixed grid plot. So we're going to use a different function here. So you've seen ggplot. You haven't seen ggdraw. Let's look at it. So ggdraw is also a cowplot function. The description is straightforward, but again, maybe not so helpful. It simply says set up a drawing layer on top of a ggplot. I don't necessarily know what that means when you read it. I assume you don't either. Basically, what it's getting at is it's saying, hey, we have some sort of ggplot object, and we're gonna like throw a bunch of other stuff on it. I think that's sort of the best rough interpretation. This is one of those cases where I think the help file, the sample code in the help file is almost always the best place to start, because I think you can read about ggdraw and you can look at the inputs of that function, and it doesn't necessarily point you
to the right way to go. And so this is a case where like I would always suggest copying the example code, pasting it in your console, and then putting your stuff in to make it work and look like the thing you want. That's essentially what I've done here. I've pasted in this code from our course materials. We start with an empty GG draw call. Now we know we want 3 plots in this grid. So we're going to have to call draw plot 3 times. That's another function you haven't seen before. If you run the help file on draw plot, it's simply a function. It says it places a plot somewhere onto the drawing canvas. So again, fairly vague. The important part here is how you specify that somewhere. And so what the help file reads is it says by default coordinates run from 0 to 1, and the point 0, 0 is in the lower left-hand corner of the canvas. So this I don't think is the case for all plotting stuff in R, but in general, when you're living in like ggplot, Plotly, cowplot land, you can think about this grid as being on a 0 to 1 scale. So 1, 1 is the top right-hand corner if you're facing it. 0, 0 is the bottom left-hand corner. And so you can specify numbers within that to control how things are placed. So we know we want 3 plots, and we want them to be of different widths and heights. And so we want that iris plot, the cars plot, and the diamond plot. And what the sample code does is it makes 2 of those plots like half height, half grid height, one of them half grid height and half grid width, one of them half grid height and full grid width. And so if we delve into the code, we can read what's going on here. So plot iris, we say x equals 0, y equals 0, width equals 1, height equals 0.5. So what's going on here? What it's saying is that iris will be anchored at the 0, 0 point, so the bottom left-hand corner. Now it's going to be 1 unit wide. So we've talked about how the grid goes from 0 to 1. So if you say 1 unit wide, that's saying the whole grid. So it's starting in the bottom left-hand corner and it's filling the entire grid. Now specified the height, 0.5, half the grid. So if we were to just plot this, and we're going to cut off that code for now. You see we have this panel, or you can observe we have this panel that has an empty top layer and a full bottom layer, because we've said that this panel, we're only plotting one thing and it's half tall and all the way wide. Let's add in another plot. Add in the cars plot. So in this case, we're going to again anchor it at x equals 0, but now we don't want it to plot it on top of supple length. We want to plot it on of the iris plot. We want to plot it above that. So we're going to start halfway up where the iris plot stopped. So we're going to anchor it at x is 0 again, so on the left side, but halfway up the grid. Now in this case, we want it to just be the left-hand upper panel, the left-hand corner. So we're going to say it's half the grid wide and half the grid tall. Okay, now we're getting somewhere. So if you were to take that y call and modify it to 0, what actually happened here is R and cowplot took that miles per gallon plot and just threw it on top of the iris plot. Let's edit that back. Have our plot again. Okay, let's add the third plot. So in this case, we know we want the diamonds plot to be the upper right-hand corner. So we need to anchor it halfway up and halfway over. So x is 0.5 and y is 0.5. And then we need it to be half the grid tall and half the grid high, just like the cars plot. If we run all that, that is starting to look pretty sharp. You can add labels on top of all of those using the draw underscore plot underscore label command. And so this starts to say, what this allows you to do is specify where the labels go and what those labels say. My code broke there because I didn't have the parenthesis in the right spot. Okay, so if you run all that example code, nothing happens. I'm just lagging here. Let's go ahead and clear my plot window. There we go. Okay. And so then you could take the A, B, and C call, for instance, and you could make it slightly more informative. So panel A, right, that is the MPG data. Panel B is the diamonds data, and panel C is the iris data. There we go. You can see where you can observe where those titles show up. So again, I'm not going to spend too much time showing all the different permutations of that. Again, they're functionally infinite, but I wanted to show you how to get started. Again, I think likely the way you're going to approach this in practice is you're going to kind of build your way there. It's kind of tough to like get the plot looking right the first time. So generally you just start adding pieces and tweaks and adjusting things, running it, viewing it, viewing it until you end up with the plot you want. So it is a bit of an iterative trial and error process. And so if you feel like that's what you're doing, doesn't mean you're doing it wrong. It's typically sort of the way we all end up approaching this. Oh, and you know what we forgot to do? The one rule of let's load our GG themes package. And let's say theme W. Yeah, that looks pretty good. It didn't alter the underlying plots. It altered the underlying grid. So that's part of what I wanted to show you here is you can use ggplot calls. They interface with cowplot nicely, but it might not always behave the way you expect. So what happened here is this theme setting acted on like the entire cowplot. It didn't act on the individual plots you drew. There are ways to modify that. You know what? That's a rabbit hole. We shouldn't get into that for now. Always set a theme, but know that if you're working in cowplot, it might act in a slightly different way. All right, so next thing we want to talk about here is how to actually go about saving one of these plots. So simplest thing you can actually do to save a plot is the ggsave function. And you can actually, you don't have to set anything. At some point, you're going to want to use settings, but you can simply say, I want to create a plot named test plot.png, and then I want that test plot to actually be the plot object fixed grid plot that we just made. So the cool thing here is that if in ggsave, it's smart enough to know that you want to actually create a PNG file simply because you specified file name that ends in .png. So you could say .tiff, you could say .jpeg. Any of those things should work. Sometimes things get a little wonky, but PNG always works, and I always recommend going with that. So I'm just going to run that. There's some default settings here. So when R sort of visualized this under the hood, it said, I think this should be a 5 by 5.59 inch image. If you go to your file setting and here in right in my base repo folder, there should be a plot called testplot.png. It's in that base folder because I didn't specify any sort of subdirectory to go in. I just said save it in the main working directory. We could create a folder called figures and then resave this plot as the file name figures/testplot.png. And then if you went into that figures subdirectory and clicked on the plot, hopefully what will come up is that PNG image. You'll notice if you do that, it doesn't look very good. So the reason is that the default save settings don't always sort of specify like the granularity and the layout you want in terms of like, you know, like dragging it around so things aren't distorted in a certain way. So again, that's often something you'll have to do a little bit of trial and error on to say the best way to actually produce this image is to make it like 4 inches tall, 6 inches wide, 300 dots per inch, that sort of thing. Most of those settings are available right in the ggsave call. So for instance, you could say width 6, height equals 4, 4 and 6 what? Well, there's a setting for units, and you can just say IN as a character string or inches. You can set the dots per inch. Let's say 450. That should look pretty sharp. All right, so now I've resaved this object test plot again. It still looks bad when I pull it up on my computer. Maybe it looks better on yours, but nonetheless, you're sort of off and running on how to save plots. All right, last thing for this video, Plotly. We're not going to spend a lot of time on Plotly because it's frankly a little bit of a diversion, but we want to show it to you because it gives you a window into sort of like interactive, non-static things that are possible. So if you don't have Plotly, Plotly installed already, pause this video, install it, then come back. All right, you're back. Library Plotly. So we're just going to use that simple iris data set. I'm going to copy and paste the code in from the course materials again. So this will be that same plot we're familiar with, sepal length on the x-axis, petal length on the y-axis, filling the color by species. If you enter that plot into the console, it's that same ggplot image you're already familiar with. So now what we're going to do is we're going to call a plotly function called ggplotly, which, as it might implies, in the description, it says this function converts a ggplot object to a plotly object. So easy enough. We know how to work in ggplot, so we make a ggplot, throw it into plotly, see what happens. And what happens is you end up with a alternate version of that ggplot, but it's now something different. It's actually like a live HTML page where you can hover over these different points and see the metadata. So if you hover over one of these points, it'll say the sepal length is this value, the species is this value. You can modify that, you can move it around. There's ways to make this even more complex by actually allowing people to interact. You can zoom in on particular features. See if I know how to zoom out now. I don't know how to zoom out. No. Reset. There we go. It's back. One thing I do want to highlight here, and this is how you know it's not a normal plot, is we've typically viewed things in the plots tab in our studio. In this case, in Plotly, it shows up in the viewer, because what's actually happening here is it is generating like an HTML page and not a static plot. And so that's what allows you to like hover over it and visualize the data. So you can, if you it doesn't show up. If you hover over this like piece of paper with the little arrow in it next to the broom in the viewer panel and you click on that, it actually opens that same plot in a browser tab. So in my case, it showed up in Chrome, and you can hover over things and it kind of highlights, oh, this is actually HTML and not just a static plot. All right, let's leave it at that. This video is long enough. We will see you in class on Thursday. Let us know if you have any questions, and be well. All right, thanks, y'all.